everybody, and welcome to the June general meeting of the Lehigh Valley Amateur Astronomical Society, being held online still, even though we've entered the code yellow phase of the response to the first wave, hopefully the only wave of the pandemic here in Pennsylvania. We are recording the meeting, and I'll be editing the recording and putting a video up on YouTube later on, because our meetings are supposed to be open to the public, and I didn't want to just make the Zoom meeting open to the public, but we do also have a couple of new members here that we'll be welcoming later on tonight. So our plan will be, I will go through our entertainment for tonight that I am providing. Our program will be first, and then we'll have a brief discussion session / break / free-for-all for a few minutes, and then we'll kind of come back to order, and we'll do a brief informational session where we welcome the new members and share a couple of other things before we quit. So hopefully the program will take about an hour. I've tried to cut it down to the point to get it to fit into that, and you know, this is an experimental thing, so if you get bored and you want to sneak out, I won't take it personally. You know, this might not be for everybody, but I think you'll find it interesting. So my name is Rich Hogg, for the new guys who are just showed up. I'm the director of LVAAS. For now, we'll be electing new officers towards the end of the year. And I'm also a major technology nerd with some experience in designing semiconductors and playing around with computers since I was a kid, and interested in astronomy since I was a kid. And a few years ago, I took a look at this program, which I'm going to show you tonight, which is called Space Engine. It's a program for the IBM PC, and it's available on the Steam platform for, I think, about $25. And it was written by Vladimir Romanyuk, a Russian programmer and astronomer, and amazingly creative guy. And he developed this program, and I'm going to share you now what the program looks like and start telling you about it. So here we are now on a simulated planet Earth in the program Space Engine. We're on top of a simulated Pennsylvania hillside looking at a simulated sunset. And I have the clock stopped right now, but I'm going to start it rolling. It's about 5:35 p.m. on December 20th of this year. And we're at Pulpit Rock. So there's some things about this simulation that are great and some things that are not so great. One of the things that's, I think, kind of great is, you know, look at the sky and the colors in the sunset, you know, lightly overcast. We have lens flare. We have some internal reflections from the lens. You know, he handles these lighting effects really nicely. And the clouds are sort of, you know, pretty good looking, although we'll see some problems with that later on. If you're seeing this at a high enough resolution, you'll notice there's some pixel jaggies along the horizon line there. The big problem, of course, is there's no trees because he didn't bother with trees. The point of this simulation is not to deal with planet Earth. It's to deal with space. So we're just starting off on planet Earth. You know, so there's the detail on planet Earth is limited. So I said, you know, we're sort of at Pulpit Rock, based on the shape of the hills. You know, they're roughly right to a resolution of some fraction of a mile, maybe, with, like I said, no trees, no rocks. You can pick out some of the bigger features from outer space, and by the latitude and longitude, we're actually several miles off. By the latitude, we should be down in Maiden Creek Lake or something like that. But and as the clouds start to clear up, and I'm actually going to fast forward a little bit. I'm going to speed up the passage of time. You notice that the clouds sort of have a pixelated, squared off shape to them. We're looking at them at an oblique angle, so the squares are isometric, you know, projection for us. So yeah, you can see some things about it that are obviously a computer simulation, see some things that are pretty nice looking, really cool. And that'll be a common theme. You know, everything has its limitations, and you know, for an individual effort in computer programming, this guy's done a really marvelous job, and I hope you'll appreciate some of the things we see. I want to let it get a little bit darker here, and there the first wonder of the celestial night pops out, and I'm going to pause it again, and I actually want to zoom in and then show that to you from the ground here. This is actually a real thing that's happening, and I'm going to zoom in with my telescope mode here. And it's not one planet, it's actually two. And this is really going to be happening on December 20th. Jupiter and Saturn are coming together in what is known as a great conjunction. And I'm going to turn up the brightness a little bit, and I'm going to stop the clock again because I don't have a tracking mount on this telescope, right? So we'll be able to see Jupiter and Saturn and its 4 moons, and plus one extra fake moon there. It's really a star in the background, and the rings of Saturn and Saturn's moons all in the telescope at one point in time. And as long as the clouds aren't in the way, it should be pretty spectacular. I think this is the minimum separation between the planets will be 6 minutes of arc, which it's closer than they've been in centuries. So a really neat event coming up. There, back to normal exposure. I have controls on the camera. I have controls on the zoom ratio. I'm going to pan the camera around to the east. So we're actually looking out over the lights of the Lehigh Valley. And on your screen there, you should, above, right in the center of the screen is the Hyades and the Pleiades at the top center of the screen. And it's time to start traveling. It's time to launch into space. By what I'm going to do is tell the program to slide the camera sideways so it looks like we're moving up. And then I'm also going to start increasing the speed. And then as we're doing that, I'm going to rotate the camera down so we can see the ground we're leaving behind. I just want to take a quick look at that. And I'm going faster and faster as I come up over the Lehigh Valley. And now I'm going to transition to going backwards now that we've rotated. So here, okay, we're looking at our region on the ground. Oops, let me go the other direction here. Get it north to the top. That's the lights of Allentown, Bethlehem, Easton right in the middle, and the other cities around us. New York to the right, Philly down south. We can see Baltimore, Washington, Reading, Lancaster, York, Harrisburg, and that banana-shaped thing up the top, that's the Scranton, Wilkes-Barre, Anthracite region. And it's kind of fuzzy, right? It's not a really high-resolution picture of planet Earth. And that's because it would just be too much darn data in the program to represent all of those things. So he limits that in order to keep the download size manageable. And, you know, if you didn't put some kind of limit, you would have more data than would fit in anybody's computer. So the point of the program is not to represent Earth, it's to represent space. But we're still looking at Earth, and as we climb up higher, you remember it was just an hour or two after sunset, so the western half of the United States is still illuminated, and the camera exposure adjusted automatically so that we didn't blind ourselves with too much light from Earth. And that meant that the city lights on the right-hand side faded out. And we can see, of course, you know, the landforms and the Pacific Ocean and the clouds and a nice little glint of sunlight off of the Pacific. And just real quick, I'm going to use the telescope again to zoom in on the limb of planet Earth from outer space. And you can see he even does, you know, you can see the atmosphere. If you look really close, you can see some cloud layers over there over the Pacific that are above the surface of the Earth. And you know, within the atmosphere. So let's find our first space destination. It's down this way somewhere. There it is. It's the moon. And it looks small. That's because the way the thing is set up, the camera is set up assuming you have a 45-degree field of view. And you can't really go much narrower than that and hope to navigate around successfully. So if you set as far from your screen as it is wide, then things will look about the right size. Now I've been pushing the increased speed button, and I got to the point where we're making progress in getting to the moon. We're going pretty darn fast. A substantial fraction of the speed of light. And then I hit on the brakes to slow us down before we ran into it. And I did that better than I've done a lot of times in practice. You know, the program manages the brightness of the view for you, but you kind of have to manage the speed at which you're traveling yourself. And that's a big deal because, you know, if you go too slow, it takes you forever to get where you want to go. And if you go too fast, you crash into things or go zooming right by them. And I almost know how to drive this thing, but I keep pushing the wrong button, so I apologize for that. I have a button here that downshifts by a factor of 10, and I'm going to use that now, and I'm probably going to have to use it again. I'm going to bring us in for a landing really briefly here in this crater. I should know the name of it, but I kept changing my mind about which crater to use, so I didn't succeed in memorizing the name of the crater. Downshift again. Maybe that was a little too much. Upshift in this smaller increment. I could try to do a soft landing, but you don't really have to. You can just kind of bang into the planet's surface. I think we landed in a crater, though. Climb up so I can get a view here. Yeah, that's a little bit better. So now we can sort of see the crater limb. Well, look at that. You can see the backscattered light from the sun. It's simulating how the light scatters back to the camera when you're looking just opposite the sun. He does a lot of details like that very nicely. There's planet Earth. So we got our own little blue marble picture here. And then if we go over this way, of course, there's the sun. So the moon is a lot like the Earth in that it's got, you know, some detail, but not a huge amount of detail. And that flashing effect, I'm not sure what's causing that. That's but what I've done now is I've launched off the surface of the moon and got up into space again. Because I have a lot of things I want to show you, so we can't waste a lot of time here, right? Somewhere over this way, yep, there it is. This is what we were looking at before. Jupiter and Saturn. And now just to show you, I'm going to turn on the, I don't know if you can read this, hopefully you can, but I need to read it. I'll read it out to you. I'm pushing the go stick full forward to go towards Jupiter and Saturn, and then I'm going to start pushing the upshift button, 1,000 kilometers per second. But now we're going the speed of light. Let me turn off that arrow over to the right. We don't need that right now. Now we're going 10 times the speed of light, which you're allowed to do in this program. It's not a relativistic simulation by any means. And you can see finally we started building up enough speed to get the sun to slide off the edge of the screen as we went past it. Now we're going 100 times the speed of light, and I'm going to bump it up a little bit more even. And now we can see some evidence of motion. Jupiter and Saturn are separating in our field of view. And I'm going to kind of go cruising right past Jupiter and head out to Saturn. Yes, you know, they look together in the sky, but actually they were a long way separated in space. One was way behind the other. And I have to downshift to make sure I don't go past it. But I'm going to pull us into the Saturn system here so we can enjoy a couple of views here before we take off for other parts of the universe, right? So the Saturn system, it almost looks like one of those Cassini spacecraft views. And I'm sure it's built up using data from that, but the advantage here is we can maneuver around it on our own. The one flaw in these views is that the moons are actually being rendered too bright right now. The program has a problem. It has two different views. I'm sorry, somebody have a question? Okay, I heard a noise. The program has two different modes for showing things, and when it shows them as points, they're too bright, and then when they go to the full rendering, they get too dim for a while. I want to come down here towards the ring plane and just show you the rings real quick, because they have some texture, they have some detail to them that is, I don't know, maybe it's not that realistic, but it's kind of cool, right? Oh, I just went through them. Sorry about that. Too fast. And they're not moving because I stopped the clock when we were looking at Jupiter and Saturn from the surface of the Earth. So now I started the clock, and now they're moving in a funny direction because Saturn is moving in its orbit. But what I can do is I can click on Saturn and then hit that button, and that locks us into Saturn's coordinate system. So now we're synchronized with Saturn in terms of our XY coordinates. The rings are still moving. Sorry about that, a little too quick there. The rings are still moving because they are orbiting around Saturn. And if I can even like try to match speeds with them here, so we get close enough. It seems to me, if I recall correctly, in an earlier version of this program, the rings were represented as little rocks, but in here they're just a kind of a texture painted on a big, enormous flat plane. And turning the computer on for a second so I can read off the speed. We're now going 10,000 kilometers per second towards the edge of the ring. Wrong button, I'm sorry. And now we're going 100,000. Now we're going, no, I'm sorry, 1,000 kilometers per second. Now we're going 3/10 of the speed of light, and it took us that much speed to get across the rings. They're that huge. That's how, you know, one of the things this program did for me is it really gave me an appreciation for the scale of things, which I hope it comes through for you guys. For me, it comes through because I'm controlling my speed. And I've maneuvered this up here over the North Pole of Saturn so I can show you that pretty hexagonal cloud formation that they've modeled so nicely in this program. But where I really want to go is down here into the shadow of Saturn. This might be the prettiest sight in the solar system, both in reality and in this simulation. And it's hard to say which one is better. Probably reality, but you know, you don't get to see it. We did get one picture of this from Cassini. Here we can maneuver and get whatever picture we want, right? I need to be up a little higher like that. So we're seeing the Saturn system with all the rings backlit by the sun, where the sun is occluded by Saturn. A lot of nice colors and nice effects like that. And it's great that he did a great job of modeling this. And we can move around and get effects like letting the sun peek out over the edge a little bit and get some lens flare and stuff like that. I think that's pretty cool. I don't know. I mean, it looks pretty close to what I remember of that Cassini picture, and it's probably fairly realistic, but it's just a pretty darn nice representation of something that's real anyway. I wanted to make sure my camera was set up properly. I got us up here above the solar system plane now. And I have to see if under pressure I can recognize a constellation here. Oh yeah, there we go. There's Lyra. Shoot, where did I put my cheat sheet? I don't want Lyra just yet. Although I'll settle for it. I should know my way around the sky better than I do, but I'm always looking at it from funny angles in here, and it confuses me a little bit. Where I want to go from here is, oh yeah, way over that way. Okay. Let me slew down in this direction, and the sun's kind of in the way. And there's Saturn again. There's what I'm looking for. We found it. Orion, of course. Orion's a really busy piece of the night sky for us astronomers, and it's also a really busy section of interstellar space. So I thought it would be fun to go take a look at it. Now, to do this, I'm going to use, this is called the velocity vector, and it's the only thing in the program that can be used for aiming. And we're already moving pretty fast, but actually I have to, no, that was one of Saturn's moons, I'm sorry. We weren't moving at all, but now we're moving fast. How fast are we moving? Not fast enough. We're only going the speed, a little over the speed of light. We have to go a lot faster to get where we're going. How about, wrong button, 10 times the speed of light, 100 times, 1,000 times. Well, now we're measuring in astronomical units per second, 10, 100. Every time I press the button, it goes up by a factor of 10. 0.1 light years per second. And finally, we're starting to see Sirius slide off the edge of the screen here. So what did I have to, between maneuvering around the Saturn system to maneuvering interstellar, I had to increase my speed by a factor of 10, like 6 times. Another factor of 10. Another factor of 10. And now it's starting to look like Star Trek. Now we're finally getting up to warp factor 2 maybe, or something like that. And I'm going to do it one more time. So we're really cruising now out there towards the Orion system. And then I slam on the brakes before I go too fast, because there's the first of our targets. We've arrived at the Flame Nebula. And I'm going to switch the camera mode to high dynamic range mode so we can see a little bit better. And I'm even going to bump up the brightness a little bit since we're doing this on Zoom. And it's not a really great picture of the Flame Nebula. And the relationship to the Horsehead Nebula behind it there probably looks a little bit wrong because of the three-dimensional nature of it, and we're really close right now. But I want to point out I have 2 different controls. I can pan the camera left and right, and I can also slide the camera like it was on rails left and right. And they have, you know, when I'm sliding it, obviously the things that are farther away don't seem to move, but the things that are closer move opposite the camera. What I can also do is I can cross those 2 controls against each other and coordinate it properly, and lets me orbit around the object so we can see it from different sides and get an idea of its 3-dimensional shape. And again, this is not necessarily an accurate 3-dimensional shape because we just don't know. But the whole point of this program is to do a fairly good job of representing the stuff that we do know, and then to fill in the blanks with you know, estimates or sometimes just made up data to give us a good experience, right? So we'll cruise over here to the Horsehead Nebula. Take a quick look at that as it gets centered up on it here. And it's not, like I said, it's not a very good picture of the Horsehead, but it has the advantage of being 3-dimensional. So I can rotate around it and we can appreciate it as what it is, you know, a kind of a dark cloud of dust in front of a bright, you know, hydrogen nebula. So it's creating the silhouette. And as we get on over on the other side here, we don't see it because the bright nebula is in front. And there's a Flame Nebula again in the background with the Milky Way across the top of the screen. And again, the brightnesses are kind of off because I put us in high dynamic range mode. There's the Larger Magellanic Cloud. And now we're back to about where we started. I went a little too far, but that's all right. We can actually drive right through the Horsehead Nebula, come out the other side, and cruise over towards the Orion Nebula. where we'll get into the dark cloud part of it, but we still can see the trapezium. And it all looks funny because we're approaching it from a weird direction. Sorry. We can sort of orbit around the trapezium and take in its three-dimensional shape. And again, I don't know how accurate this is, but you know what we really want to do is just drive right into the middle of it, right? Well, it's not that impressive, but it gives us an idea maybe of what the night sky would look like from the middle of the trapezium. And those stars are really bright, but there's not that many of them. They're spread far apart. So I don't know, there's one somewhere around here, I'm sure. I seem to have lost them. Oh, there's one. If we go back to normal brightness and normal exposure mode, you see the nebulosity kind of fades into the darkness. And even if we get that bright star off the screen, it's still pretty dim. That's one of the lessons of you learn of astronomy is and space exploration is getting close to these nebulas doesn't really make them brighter, it just makes them bigger. I'm going to focus us on Earth, and for our next trick, I'm going to take us back to Earth temporarily using the autopilot. Let's do it faster. Come on, let's get there. And then rise up above. I hope we're going up above. I forgot to look to see which way north was. There's the moon. The moon's illuminated from the left. So I think this might be the southern hemisphere. Yeah, there's the SMC. So I got to swing around and get up to the north again. Too far. All right. Play this game again. Try to find a constellation that I recognize. There's the Pleiades. There's the Pleiades. The Hyades are there. If I go this way, let me get away from Earth. Somewhere over here. Yeah, I found it. There is Lyra. I'm doing pretty good here. Good thing I practiced this. Okay, same trick. I want to aim. Need to turn on this and turn on this, and then use this to aim. And those of you who have some experience know what I'm aiming at. Turn that off, and we'll go cruising again. And this time I'm going to leave the display on so I can keep track of how far away I am, because I want to stop when I get within the neighborhood. Otherwise, I'll go zooming right by it. So now we're finally we're climbing up. We're now 5 astronomical units from Earth. 10. We need a lot more speed, right? We need to get up into the light years per second regime. So I'm using the fine control, but I'm just standing on it to I'll use the auto repeat until we get up to interstellar speeds. And I need to get us out to about 650, 700 light years from Earth. And the experts will recognize that that's wrong. There, I drove right by it again, but just barely. Because the Ring Nebula, which we're now looking at, is actually 2,200 light years from Earth. But I think old Vladimir, when he set up the program, he looked up the number for parsecs and put that in instead of light years. So he got this set up a little bit wrong, but nevertheless, we found it, right? So the Ring Nebula is a favorite telescope target, and it's a pretty good representation of it. But of course, with the telescope, you can't do this. You can't look at it from the side direction, where we see that it is actually kind of a fattened ring. Go back to high dynamic range mode, and we can see you have the band of bright hydrogen gas around the center, sort of they call it a football-shaped cloud of oxygen emitting gas in the middle, and then the dimmer outer shells of hydrogen from earlier expulsions around it. And then there's the small Magellanic Cloud again in the background. That keeps popping up. And there's a larger Magellanic Cloud. We're sort of handing landmarks in this I call it a game sometimes. I call it a simulation other times. And now we're behind the Ring Nebula, looking at it from the other side, and we can drive right into it. And I don't know if you can see it on your screen. Let me go side to side a little bit. One star is moving as I go side to side. That is the white dwarf that is left over from the supernova that created the Ring Nebula. And I'm not going to take the time to visit it, but if you do in this simulation, it's a binary. So I don't know if that's realistic or not. But one more time, I'm going to go home. And let's see. Okay. I recognize South America. I recognize the Gulf of Mexico, I think. Yeah. The sun has not set on the West Coast yet. That way's north. There's the Big Dipper. I need to go which direction from there? If only I was an astronomer. I know my way around these things. Okay. I need to go over this way. And I'm feeling the pressure of finding this, so I'm going to cheat. I hate to cheat, but I'm going to cheat. There's what I'm looking for, Hercules. Yeah, I turned on the constellation lines there so I could find it. So now I want to aim again. For right here, to head for another favorite astronomical target at enormous rates of speed. Going the speed of light now. I'm standing on the accelerator button. Astronomical units per second, 100. Now we're going the speed of light, 10 times the speed of light, 100 times the speed of light. Let's get up to about 1,000. That was a little too much. I want to get up to about 22,000 light years here, just outside the Milky Way, actually. And I never realized until I played with it in this game that this target is actually barely outside that Milky Way. I'm sure I probably had a chance to read that fact somewhere, but I never paid attention. Should be right out here somewhere. Oh, there it is. Yep, the bottom of the screen. So I aimed for it manually, and then, oh, I went backwards accidentally. Sorry. It's the Great Globular Cluster in Hercules. Or in a three-dimensional point of view, it's way behind Hercules. It's just outside the disk of the Milky Way galaxy. In real life, this has, we don't need high definition here. In real life, this has 300,000 or 400,000 stars. I think it has almost 100,000 stars in Space Engine, kind of orbiting around each other in a ball. There was the Milky Way behind us. Let me back up a second so you can see that. See the Milky Way there dimly in the background? And the Magellanic Clouds behind that. Now, of course, while we're here, we got to drive right in and take a look at what things would look like from the center of the Hercules cluster. The sky's a lot clearer than over by the trapezium, right? There's not a lot of nebulosity. It gets blasted away, if there's any there, blasted away by all these old stars radiating. But boy, there's sure a lot of bright stars in the sky. And what I wish they would do is model the orbits of them. See, I need to point back towards home and slide out of here and go to a different mode so I can see. I wish they would let us see the orbits of those stars if you speeded up the clock, so that you could watch how they orbit around the globular cluster. But one thing this program does not do is the motions of stars. The planets move around the stars, the moons move around the planets, but the stars are fixed. And there's practical reasons for that too. I need to get out into space here a little bit better so I can see what I'm looking for. Should be somewhere around here. Oh, come on. Maybe I didn't swing over far enough. Yeah, there it is. Slightly wrong direction. Next target, the Andromeda Galaxy. And I sort of figured out a way to find it from out here so I didn't have to go back home again. And in normal mode, it kind of looks pretty dim. I'm going to put it back into HDR mode so we can see it. And we're going to start cruising. And this time I'm going to use the factor of 10 upshift button because we have a lot of speed we need. We're going, I was using the wrong button, sorry, okay. 100 light years per second, 1,000, 10,000 light years per second, 1,000,000 light years per second. No, I'm sorry, 100,000 light years per second. 1,000,000 light years per second gets us there pretty quick. Now, in the background, I want to point out quickly, you see a lot of other galaxies. They almost look like snowflakes falling on the windshield as the snowstorm gets started while you're cruising around in your car, right? And we'll get to that. But right now, we're just going to dive into the center of Andromeda Galaxy. And we start to see the stars of the Andromeda Galaxy. Now, where did all these stars come from? I mean, of course, the Andromeda Galaxy has stars in it, but we don't know anything about them. We don't know about all these individual stars. This is what Space Engine has done for us in creating this universe. It's a trick called procedural generation, and it's been used by game programmers for a long time. Usually they make it to build a mountain or a tree. The idea is if you don't know exactly what something needs to look like, you can let the computer generate it for you based on basically a random number. By the way, I'm going to switch between talking and touring here. There's home back that way. If we cruise out of the galaxy, we can see the Milky Way as it would look like from Andromeda. I want to go the other direction. I want to go farther out. And while we're doing that, I'm going to continue talking about procedural generation. So I need to create a galaxy full of stars, or I need to create a universe full of galaxies. And there's all the galaxies, right? And now we're going at 100 million light years per second, and I can get up to the maximum speed of 320 million light years per second. Look at all these galaxies. I mean, you know, it's bad enough to ask a game programmer to put a whole bunch of trees into a landscape for a game that's on Earth. The only, you know, that's impossible. This is beyond impossible by many orders of magnitude, but the trick is to use this technique for generating numbers that look random in a computer. They're called pseudo-random numbers. And basically, it's just a complicated mathematical formula that generates digits that you can't predict and then don't have an obvious pattern to them and pretend they're random. And a lot of times when you need a random number, you feed in like the current time of day into the formula and let it generate something that's totally unpredictable. But you can also start off with a known value. For example, right now we're a certain number of light years from Earth, almost 20 billion right now. We've just left the observable universe, by the way. I'll show you that while I'm talking. You take your distance from Earth, your coordinates, your right ascension, your declination, and feed that into your random number generator, and you're going to get a bunch of numbers out. I think the program, by the way, models redshift. I turned up the brightness really high, but everything's turning red as we moved away from it, and it's gravitational redshift. It's not. It's you know, or I don't know. It's relativistic redshift. So some parts of the program are relativistic and some aren't. But as we come back into the amongst the galaxies, the color will change back into the, you know, the wider range of the spectrum. Anyway, you generate random numbers and use and feed those into a template that will generate galaxies or generate stars within a galaxy. And you get something, if you do your template right, that looks like it's real. And the thing is, you feed in, you do this, this is repeatable, right? If I go to a different computer on somebody else, you know, with somebody else's copy of this program and go to the exact same location, the exact same galaxies are there. And if I come back later, I mean, I would never find the exact same spot unless I bookmark it. I'm cruising through the universe at 300 million light years per second, and I'm just taking random turns and so on, just to end up somewhere. I have no idea where I'm going to end up. I've never been here before, and chances are nobody in the world has ever been here before. And unless we, like I said, bookmark it, nobody will ever come here again, because this is so big. This space of fake imagined galaxies created by mathematics is so huge that you never find one if you didn't come back to it. And I just picked this one at random. Some random galaxy out in the middle of nowhere. Well, I was hoping it to be a spiral, but turns out it's an elliptical. That's all right. It's a pretty big elliptical. I'm going to cruise into kind of the outer edge of it here. And we'll see it's full of stars. Randomly generated, well, not randomly, but procedurally generated stars. Obviously, they're not real, but they're repeatable. Okay, I almost ran into that one. I'm going to sneak up on it. This is hard to do because you have to develop the knack of slowing down at the right time so you get there in a reasonable amount of time without going past it. And I found the best thing to do is to approach it at a slight angle so I can see it moving on the screen. Of course, then it does that trick where it flashes out for a second and then you lose it. And then as it starts to move too fast, I downshift to a lower speed so I don't go zooming past it. So I'll approach this star here and see what it is, a star that nobody else has seen. Hey, at least we lucked out it's got a planet. Some stars have planets, most of them do. But then you find a binary star. Oh, it's got at least 2 planets. It is a binary star. See the companion there behind it? I think that's a companion, but let's go to this planet down here. So now we're in a random procedurally generated planet around a random procedurally generated star around a random procedurally generated galaxy in a fake universe. And the planet has apparently at least 1 moon. And as we get closer to the planet, we see the planet has, it's a big moon too, or it's a lot closer to us. No, I think it's just a big moon. The planet has random procedurally generated surface features, and I'm actually going to select it and we'll look at it. It says it's a cold, arid Aquarian planet with a surface temperature of -134 C. It gives chemistry. It gives surface gravity 0.4 Gs. I think the companion looked more interesting, so I'm going to switch over to that and head over that way. Well, maybe not. Kind of almost looks like Pluto or the moon almost. Yeah, it's a cold, airless mini Aquaria. I don't know what they mean by Aquaria in this case. I'm changing my mind. I'm going back to the first one. So he has templates for galaxies and templates for stars and templates for planets, all fed by these pseudo-random numbers, generating this enormous universe. You know, and I need to do the lock onto it trick so we get into its frame of reference. It has craters. It looks like volcanoes. Wow, it has these interesting stripes on it. That's an interesting feature. I tell you, I wish, I could spend hours and hours showing you stuff and this stuff that I've seen before that I thought was interesting and stuff. Keep discovering new interesting stuff in here. I think this is, I wanted to get the automatic horizon thing to kick in there, but it doesn't want to do it for some reason. All right. Hills and valleys and craters. We are not locked on here for some reason. I'm not sure why. Oh, rotation. There we go. I was locked onto the center of the planet, but I wasn't locked onto its rotation. So we can get down here close to the surface of the planet. I'm going too fast. We're still going 1,000 meters per second. We get down to a walking speed and get down close to the surface here. Down to a remarkably low level of detail. More detail on the procedurally generated planets than you have on Earth. And that's because we don't have enough memory. Oh, look at this hole. We're going down in this hole. We don't have enough memory in the computer to remember all the details of planet Earth, but for a procedurally generated landscape, you don't need the memory because you can generate it anytime you want to. You feed the coordinates into the pseudo-random number generator, and let the output populate the template, and you get the data, the topography of the planet, whenever you want to. I like how those hills are poking up over there. Kind of a nice little mountain over there. Hope I'm not making everybody dizzy. And how am I doing on time, by the way? Yeah, so 8 o'clock. So this is about an average planet. I found some things that are really much more interesting, and things that are kind of a lot more boring. But I'm gonna put us back into space here and take one last look at it. Yeah, I guess it's kind of a crack that's making the curved nature over there. And we got craters, and I think there was sort of like an ice volcano over there on the right side of the screen now. I could spend hours showing you stuff in here until I'm exhausted. I could spend, you'd probably get tired of it eventually, but you could spend, you could have everybody on Earth spending 1 million lifetimes exploring what's in this and never finding everything. Earth is that away. And how far is Earth? Let me lock onto Earth here and figure out how far away it is. It's 15 billion light years away. We're almost at the edge of the observable universe. Depending on how you measure it, there's a couple tricks of that, but rather than take the time to pilot home, let's go home by automated means. So now there we are already. So that is the end of our tour. I hope you enjoyed it. I'm going to stop the sharing for a second. And hello, Tom. I see you joined us in there. And there's Brett from Muhlenberg. And Earl is here. And Dan Fluryshack. I see a few people have joined us since I started the presentation. All right, that's the end of the tour. I can take requests if anybody wants to go see anything in particular for a couple minutes, or ask any questions. Brett, I see you have your hand up. You want to unmute yourself and go ahead and have a question?
Oh, I tried to, that was meant to be clapping, that I enjoyed it. It wasn't a question.
Oh, okay. So yeah, that program costs, like I said, about $25, and I tried to make it look easy. It does take some practice and learning to be able to drive around, and it can be frustrating if you're not a patient person. And this is actually my second experience with it. I looked at it for the first time a few years ago, but you know, it's a kind of a work of fantasy to a certain extent, but it's solidly based in science, and I think it has some learning value. So I think it's pretty neat. Um, and like I said, if anybody has any requests, we can go look at things I probably haven't looked at before. um,
Bill wants to know if you can find the Tesla.
I don't think that's in there, Tom. I think it actually has um, it has a mode where you can add things to it. And I saw there was a download where somebody had added the Apollo module on the moon, and you could actually go sit on the moon and look at it. You know, it was as they were there on the moon, so it had the command module still on top of. I'm sorry, not the command module. The lander is still on top of the landing base. But um, my brother is petting his cat Willow. Very nice kitty, very friendly.
Hey Rich, can you go to Alpha Centauri?
Yeah, we could try to go to Alpha Centauri. Let me do that one more time. All right. I have to go to the find window, and I'll type in Alpha Centauri. And it's not showing that for some reason. The database is a little funny in the way it represents things. I've had trouble finding things at certain times.
Try Proxima Centauri.
I'm sorry, what?
Try Proxima Centauri.
That's a good idea. Yeah, Proxima Cen. There we go. Oh, and I should have said go to. All right, here we go. Good suggestion. Thanks. Okay, so we ended up right in the, you know, closer than Mercury distance to Proxima Centauri. Let me back away from it a little bit. It's showing it as having a pretty dense halo there around it. I think that might be accurate. And that's probably Alpha down there moving with it now, because they are. See if I can approach this without, or maybe it's a planet. That's a planet. So it is a multiple system, a star system, but they're not that tightly bound. So Alpha, if we get far enough away, it should show up here. Yeah, that's it down there, I'm sure. You know what? Let me do this. If I can find my mouse pointer. Oh, good, I found it. I'll select it. And then see, you have to know the Greek letter alpha to get there, I guess. You have to know how to type that. Okay, there's Alpha Centauri A and B, the binary system. And there's ways of checking if it has planets and stuff like that. Gwen, did you have any anything special you wanted to accomplish while we were here?
Not really. It's just something my dad and I wanted to see.
There's the Magellanic Clouds again. It's funny how you keep seeing those once you get into outer space, at least in this thing. I don't see any planets around that one. Of course, it's a binary. Well, there's the Pleiades in the background. This close to Earth, of course, some of the constellations will still look. Let's go there. Some of the constellations will still look. Oh, I didn't mean to do that. Sorry. Still look realistic because you aren't that far away. Any other requests?
So when you're at these other locations, looking back at us, does the sun stand out? Or is it pretty dim by comparison to
Depends where you are,
where
right?
we-
Yeah, it depends where you are. Let's take a look at that. Wait a minute, I stopped the share, didn't I? I have to start that up again. That's a good question. Okay, so Earth is that way, and from the Pleiades, it doesn't stand out that much. If I hit the backspace key, I think it'll select Proxima again, and then I can go over there, and from there, I'm sure the sun will look, now I can select the sun. Good thing I learned a few of these keyboard shortcuts. And there it looks like a pretty bright star. I mean, that's, where it's going to look the brightest. It's not a huge, intrinsically bright star from an absolute magnitude perspective, but from 4 light years away, it looks pretty bright.
And by doing that rail move where you could see relative stars.
Yeah, if I go
Or-
sideways and if I go fast enough, which is now we're going 1/10 of a light year per second, now you can see it sliding back and forth across the background stars. I'll bump it up one and do it a little bit faster. Well, now we can see a couple other stars that are farther away in the background, right? Okay, that gives you a nice idea of the three-dimensional aspect of things. There's another really bright one down there at the bottom. I wonder if that's Vega. Can't tell from here. I'm sorry, that can't be right. No, I didn't get it. No, that's Capella. So Capella must be pretty close too, because it's moving pretty quickly. We can kind of keep sliding sideways here and see the whole three-dimensional star field move across in front of us. There's another one that's pretty close coming across the top of the screen. It was off to our right, but obviously not too far away. It says it's the star Kide / Delta 2 Eridani / 40 Eridani / Jalise 166 / 4 other names. HIP 19849. Good grief. Must be a
Just call
really
it Bob.
interesting. I'm sorry?
Just call it Bob.
Bob's good for me. I'm fine with that.
I guess one other interesting thing would be from Andromeda looking back at the Milky Way as to where Earth is in the Milky Way.
Yeah, we did that, but we can do it again
All
really
right.
quick.
I probably missed that.
Andromeda Galaxy. Go to zoom. All right. Select Earth. Center it up. Now, if I put the camera in normal mode and normal brightness, I think, yeah, it's kind of getting lost in the background galaxy there, background galaxies. Let me enhance the brightness a little bit. Yeah, it's sort of not standing out too much, but it's there. You know what? Telescope mode. Back to normal brightness. I think what's happening here is that there's a lot of satellite galaxies around the Milky Way that are in the database, and it's rendering those in the point of light mode, where it's rendering rendering the Milky Way in extended object mode. And as I mentioned before, it kind of is a bug, or maybe it's intentional to help you be able to find things, but it renders things in point of light mode too bright relative to extended object mode. So all those little satellite galaxies there kind of look too bright. But we can do the sideways sliding thing here. Actually, some of those seem to be a lot farther away than I thought. I'm surprised. There's the Magellanic, one of the Magellanic Clouds up there on the upper to the left of the screen. Farther away than I thought. No, I guess I knew that. Whatever. It almost seems like, no, that's a reflection of me on the screen. I thought I was seeing something else. Oh yeah, so the small Magellanic Cloud is right at the top of the screen. Large Magellanic Cloud is below it. The Milky Way is at the bottom. And if I increase the speed and sort of orbit around, we can, I can see there's another little satellite out there. I wonder what that is. See what I'm talking about? Right down there. Wonder if I can select that. What did I do? I lost it. Did I lose it? Shoot. Oh, what did I do? That looks like the Needle Galaxy. No, that's the Milky Way. Oh, there it is. That, yeah, there it is. Problem, you push the wrong button, you're going too fast. Okay, it's right down there. If I get my mouse on it and select it. It's the Carina. It says it's Carina DSO. I'm not familiar with that. It's got a whole bunch of designations. Carina DSPH ESO 206-220, E206-G220, FPGC 19441. You know what? We're going to go there. Take a quick look at it. And it's a little elliptical mini satellite galaxy, apparently. I don't know why it went that way. I thought it was going backwards. Yeah, well, there we go. Okay. Any other requests?
Let's see what Beetlejuice really looks like.
What this program thinks Beetlejuice looks like, I'm sure it will be interesting, though. That's one I haven't looked at, actually. Looks kind of lumpy. Whoa. What did I do? I turned the brightness up really high somehow. There, okay, so it's kind of a lumpy looking star with a lot of spots on it. That sort of agrees with what we know about it, actually, with big clouds of gas around it. And it seems like it has a little planet there or something, some kind of little companion there, off on the right of the screen now, following us around as we try to orbit around Betelgeuse. I'm not doing a very good job. Let me turn down the brightness so we can appreciate the texture a little bit more. That's kind of weird looking. I like that, though. We can actually come in really close now that we've turned down the temperature. Yeah, we actually landed on Betelgeuse. I need to back away a little bit so I can see something. I'm just,
About the marshmallows.
yeah, really. I think we have some rendering artifacts here. We have these jagged shapes. I don't think those are realistic.
How about
That's the condo you rented.
How about a black hole, Sagittarius A?
Yeah, now that is a really interesting. I have looked at that, and that is really interesting. Actually, I can get there easily. I say focus on the galaxy, and Control G takes me to the center of it. And the center of our galaxy is Sagittarius A, which is a supermassive black hole. And I don't know if I'll be able to, I tried to recreate something I'd done before, and it has the whole cluster of stars around it too. Okay, where'd it go? It takes us there, but then we can't see it for some reason.
It's the black hole.
No, it has the accretion disk though. Oh, I'll get the camera in the right mode, you can see it. Managing speed and managing your camera exposure are two of the big challenges in this program. Whoops, too far. Didn't hit the downshift quick enough. So we see the accretion disk, and if I orbit around it here a little bit, maybe you're not allowed to do that due to relativistic effects. Now we're getting there. Sorry about the wobbly view here. Okay, I think if I go to HDR mode, yeah, you can also see the jets being ejected from the along the axis of rotation. Oh, and look at that! I didn't notice that before, but we're actually getting some. You see it? The lensing effects of the background stars. You see how we're getting some of the Einstein rings of the background stars, and how we're getting the funhouse mirror effect. I didn't realize it did that. That's pretty cool. We can actually get in. I've done this before. Hopefully we can do it again. Somewhere in here. Oh, now I can use my. Okay, that's not helping me. But if I sneak in inside the accretion envelope here somehow, you can actually get to see the black hole. Whoa! What the heck? That must be the. I don't know what that is, but it's pretty cool. What I was trying to do is before. All right, we have to remember we're in the vicinity of a black hole, so things are very strange. And they might be strange because of the physics, or they might be strange because of the modeling of the physics. But somehow previously I was able to get in here and actually see the black hole itself. I'm trying to do that right now.
I'm going to turn your brightness down.
Yeah, it might hurt to tell. I was trying. Yeah, that was a good idea. Thank you. Yeah, there it is. All right. And I was in here at one point, like it is trying to do a reasonable job of modeling all of the crazy optical effects down in here. Even though we can see relatively undistorted what look like background stars there, I'm trying to rotate the view around, and it's taking forever for some reason.
It's got a lot of mass to move. Give it a break.
Yeah. Whoa. I'm sorry, I'm going too fast, and I noticed. Yeah, it's really funny right down in here. It's very confusing. The light is circling around the hole multiple times before it hits the camera, and weird things are happening, and the simulation is trying to model some of that, and it makes for a very difficult maneuvering environment. It kind of looks similar, except for one thing. There's a reflection off the surface of the black hole right there. That's definitely not right. But you know what you can do? You can go inside. I've discovered this before, and then you can turn around. You know what? I think we're zoomed in here. You can turn around and find your way back out. No, we didn't go inside. We went past it. Somehow before I went inside of it. Like in real life, it'd be impossible to avoid going inside of it, right?
Oh, you couldn't do it more than once.
I think we're inside the black hole. Question is, can we get back out? No, we're not inside the black hole. We're still outside. Somehow I actually got inside of it. And, you know, I could keep, you know, it was the one thing that was cool about it was, you know, I was headed in the right direction to get back out, but I couldn't get back out until I went faster than the speed of light. So that was kind of realistic. You know, that would be true of a real black hole. You know, you can't get back out because you can't go faster than the speed of light, but this is a computer game, so some things are not realistic. All right, black hole. Any other requests?
Can you try Epsilon Auriga? I don't have a better name for it, I'm afraid.
Epsilon Auriga? I guess we can. Ah, I forgot I clicked go to. All right. What's special about this, Earl?
This is the one where its companion, they're not exactly sure what the companion is, but it eclipses it for a period of about 2 years. And they're thinking that the companion must be, it might be like a pair of red dwarfs with a whole lot of gas and dust associated with it. So it takes a long time to, you know, go in front of it. It goes like every 27 years, it eclipses it for like 2 years. Not completely,
Okay.
of course, but still quite a bit.
Well, they don't seem to have that modeled in this. It sort of kind of looks just like an ordinary binary. There's that damn LMC again. We're actually now I have noticed that it does model stars orbiting around each other. So I've increased the rate of the clock. We're never going to get home in time now because we're now at the year 2250. But you know, if you increase the clock rate, you can actually see the evolution of you can actually see binary star systems orbit around each other and stuff like that. And what's kind of cool about that, let me back up to where we were just a second. No, I went too far. Can I reverse that? No. What's kind of cool about that is, actually, I know how to do this. Same thing we did before. Back to the black hole, and you remember it had all those stars around the black hole. Well, those are actually modeled as a multiple star system. Boy, that was a funky looking nebula we went just zooming by there, wasn't it? So if we head back there, and then we back away from that so we can see all of those, and then again, speed up the clock, you can see them all orbiting around the black hole, like kind of like you know, flies buzzing around the light on the porch on a summer night or something like that, right? Actually, you can turn on the orbits so you can see all the orbits that they're following. So we actually have pretty good data about all these stars thanks to the studies they've done on it. So I don't know if he has the realistic data in here or not. You'd have to compare or read his blog or something like to find out. It kind of looks similar to the realistic data, but it's I think, you know, it's a pretty neat effect anyway. It sort of reminds me of something else I did by accident. Let's see. Focus on Earth, center on Earth. How far away from it? We're 28,000 light years from Earth. Let me reset things here a little bit. Get back out into interstellar space. I was cruising around the galaxy one day. Oh, come on, I should see some stars out here. Where are they? There we go. And I accidentally turned on the constellations. And the constellations are actually drawn as three-dimensional lines between the stars. So I said, what the heck is that over there? And it's actually, I'd accidentally turned on the constellation lines. So as we get close to Earth, they actually will expand back out into the celestial sphere that we see around us. It's hard. You can do it, but you can sort of find your way home by just trying to find the center of the constellation. So I thought that was kind of interesting. Hey, I think that's Orion over there. It's only slightly distorted, though. Yeah, that's Orion. Sure. Any more requests? Oh, I got myself something to wet my whistle here. Let me do that.
But it did result in me changing my wish list. I no longer want to travel at the speed of light. I want to travel at 1,000,000 times the speed of light.
I'm trying to find the controls to stop the sharing, but there we go. All right. Well, thank you very much for your attention. That was fun. I guess we can kind of move on to the informational part of our program. Anybody need to take a break before we take care of a little bit of business and get finished up for tonight? Gwyn, are you ready to do the new member thing?
Yeah, I could do it. Did you want me to do second readings first or first readings?
I'm sorry, what?
You want me to do second readings first or first?
Whatever you want. You're in charge. Gwyn is our membership director, and she is going to do the thing now.
All right, I see that Brett's online tonight. Brett, is it just you tonight, or are any of you, the rest of your family, online tonight?
Well, my whole family is here, but I'm the one who tuned in. And actually, I've been waiting for this meeting all month. I wanted to get my second meeting in, and then I was late,
Yeah,
so I felt terrible. But I got in by about 7:40, so
you're good. You're good. You're here for the most important part. All right, well, so tonight will count as your second reading, so all you had to do was show up. So welcome to LVAAS. You're now a full member, so you now have full privileges. So congratulations.
Hi, everyone. Thank you.
All right,
Welcome
now
to
I'm
LVAAS.
going to go ahead and do first reading. So I know we have a few here that are here for their first readings. So I'll start with William McAlmis. I'm sorry if I mispronounced that.
Okay, it's pronounced Malcolmus.
Malcolmus. Okay, sorry. So
Well,
just tell us a little bit about yourself, how you found out about us, your interest in astronomy. Just kind of give us a brief introduction.
Well, many years ago, when I was a young person, I had actually attended at least one or two events on South Mountain, but I don't believe I was ever a member. But it's possible I was. But I at least attended some public observations up at the South Mountain facility, and I know I attended at least one or two programs. But sporadically, I've attended planetarium presentations and the like. I've just sort of always have been interested in sciences, even though I'm not involved in sciences professionally. My educational background is that I'm a lawyer and have a degree in economics, but took a lot of science as a result of just general interest. And I took a couple physics courses in college and spent some time in my college observatory. I don't remember much, but I've done some reading on my own about space. Just recently bought a telescope. Haven't really used it yet, to be frank. I live in downtown Allentown. I do have a view of, but it doesn't seem like the viewing's been very good lately. But You know, I plan to get more active. My level of experience would be as novice, but hungry novice.
Yeah. All right. Well, that's awesome. We're happy to have you. So welcome to the society. So do one more reading either next month or the following month. So whichever
Sure.
works best for your schedule. So just keep an eye on our website as to whether or not that'll be online or if it's in person. So
Will do.
to LVAAS. All right. So I want to turn it over to Mike Boyle. If he's
I'm still
Mike,
here.
are you there?
Yeah, I'm seeing a little latency. Can you hear me?
All right. Yep, I can hear you now. Just do the same thing. Just give us a brief introduction, how you found out about us, and what your interests are in astronomy.
Sure. I have recently retired. I was, marginally interested in astronomy before that for some years, but when you're up at 5 in the morning to go to work, it limits your viewing time. Now that I have time, I would like to delve into the field. I'm pretty much a novice. I'm looking for general information, different techniques, different equipment, and that sort of thing. On the internet, you see a lot of salesmanship and I guess high expectations and all that sort of thing. I'd like to get a clear review of the field before I go any further. This seems like a good place to start with all the informed opinion that I see, and I found out about the place on the internet, my favorite knowledge source.
All right. Well, awesome. Well, you definitely found the right spot. We definitely could help you out with that. It's always good to try before you buy for sure. So,
Yes.
and like I just told Bill, you just need to come back either next month or the following month to do your second reading, which is really easy. So, welcome to LVAAS.
Okay, thank you.
Thank you so much for coming tonight.
My pleasure.
All right. That's all I had, Rich, unless you have anything else for membership.
I don't think so, Gwen. Thanks, and thanks, Mike and William and Brett for your interest in LVAAS, and welcome to your membership. Brett, you're a full member now, having had your second reading, and as Gwen said, Mike and William, if you come back again next month, the month after, you'll also be full members. So unfortunately, Mike, and also you too, Bill. Due to the circumstances right now, we're not having our public star parties or doing any of our usual gatherings, and it's not really for sure if we're going to start doing that, soon or not. We're being rather conservative about our approach to reopening, but we keep talking about it obviously at the board meetings. But if you're new to astronomy and you want to get experience with observing, it really helps a lot to be out there with somebody else who's more experienced, and even our public events are a great way to do that. So hopefully we'll be able to start doing that again soon. Okay, what I want to do also is I also want to give a quick demo of this project. Now this is a kind of a side project I did, and I spent pretty much the whole month of May on this, starting from the May general meeting up until about a week ago. And I sent out email to all the members, and a few people have tried it out and did things, and a few of those people are here, so thanks everybody. But I just wanted to show it to people who are present one more time, to try to get a few other people to fool around with it, because the idea is this is a picture of our 40-inch telescope project that the club has been working on since the mid-'80s over near Hamburg. And this is what it looked like when it was freshly painted, and it was never finished as a telescope. It's been under construction for 25 years. No, more than that. 35 years. Yeah, 35 years. But at one point in time, a coat of paint was put on it, and it sort of looks something like this. And it's all apart now because the paint has failed, and the rust has taken over, and we have to repaint it. So we're having a little, not exactly a contest, but sort of a suggestion box thing to say, what color would we paint the telescope? And Gwen, I expected you would have come in here and put in your favorite color scheme, but since you didn't do it yet, I'm going to do it just to demonstrate. So I'll put a link to this up on our webpage later on.
Yeah, I haven't done it yet.
Yeah,
It's on
well,
the
I'm
list
going
of
to
things
go
to
ahead and
do.
do your version sort of as a demo. So
That's fine.
man, you might pick a slightly different shade of blue than I'm going to pick, but there was some blue paint that was actually bought for this telescope, and then it got used for the 20-inch telescope that was also never finished. And I don't know, maybe it looks something like that, but you can go there and you can click your colors. And then let's see, we want to keep the truss and the secondary housing black. We don't want to paint them a bright cover, but we can paint all the other stuff blue. So I'm going down the table here and selecting all those colors and saying apply that color to those things. You know, I'm going to put a little more contrast. I'm going to make the door panels black. I think they might have to be black anyway. And I'm going to make the accent stripe on the back panel black also, just to give it a little bit of contrast. Anyway, there's another design for me, so I'm going to put in a title for it, black and blue, and a little description, and I got to type in my email address. Boy, I have a lot of email addresses in there. And it remembers my nickname I put in because I did this before, and I'm just going to say submit. And it's been added into the database. And now if I go to Browse Gallery, there's my design, and you can see all the other designs that other people have entered in there. There's a couple others that I put in there. There's Bob Moore's black design. There's Tom Duff's black and gray design. There's Jeff. Hello, Jeff. I see you're on tonight. You put in this nice blue and black design with the white stripes. Cool. John Kmetz put in this thingy called Nebulous, and I kind of don't get it, but it's. And then Eric put in his crazy color scheme. I'm just going to put a comment on that. And so you can go look at other people's designs and comment on them and vote on them and stuff like that. Bob LaFleur, he says this is the Eagles colors. I don't know.
Oh.
They look kind of dark to me. Anyway, fire this thing up and play with it. It's lvaas.org/paintThe40, and I'll try to get to it later this evening, but I will put a link to it up on our main page so you can find it more easily. So I just wanted to say, hey, you know, at some point later this summer, we're going to go ahead and probably start implementing whatever choice we make about the color scheme. So this is your choice right now to have some input anyway. And if you have another idea about what we should do to the telescope that you can't implement in that program, you know, email it to us. One of the things we're thinking about is we could actually decorate it with, instead of using paint or powder coat, we could put vinyl wrap like they use on cars on parts of the telescope. And on a vinyl wrap, you can have anything printed. It like just comes out of a big inkjet printer, so you can do a lot of cool stuff. All right, what else do we have to do? Is Blaine with us tonight? I don't see him on the list. Blaine has started up the LVAAS book club, and we've all picked a book, which is Sean Carroll's book, The Big Picture. I couldn't remember the title for a second. And we're planning to get together and talk about the first section, which is the first 8 chapters. So I've read those 8 chapters. I'm ready. But I don't know what our next step is. But I just wanted to mention that activity is going on, and it's kind of a nice activity for a time when we have limited willingness to get together and have big events in person. Speaking of event venues, so Bill Dollenberg, got any report on the state of South Mountain?
Hey, I've purchased the shingles we need to do the roof over the redshift, you know, the western facing roof. So we just have to get a crew together for that. I'm just looking for a day where we can do it. Now, next weekend is Father's Day weekend. It's kind of doubtful we can do anything then, maybe after that. We power washed both the Brooks Observatory and the 6-inch upstairs. So the building's looking kind of clean. And I just wanted to say to the new members, I'm usually there Saturday mornings. There's a small crew. There's only 3 or 4 of us come out. We cut the grass and paint and do things like that. So if any of the new members want to stop in on a Saturday, look things over, a lot of times we'll have the 6-inch pointed at the sun. We have an H-alpha scope plus a white light filter for the 6-inch. So if you haven't seen the sun in H-alpha, come on down, take a look. So we can do that. We can show you the rental equipment we have, things like that. It's best to contact me on the web. I do the South Mountain Maintenance where it says contact us. Just send me an email through there.
Is that opportunity available now, even in the midst of all the COVID stuff, or?
I think, yeah, there's only 3 or 4 of us there. We're outside mostly. So I don't think it's any big deal.
Thank
I
you.
agree, Bill. That's a nice idea. Thanks.
Mhm.
Yeah, so Bill is South Mountain Maintenance Director on our contacts page on the web. So if you're interested in stopping by on Saturday morning and seeing a little bit more of our facilities and maybe getting some a little bit of experience and advice, just email him, make sure he's going to be there. Earl, you're usually there on Saturday mornings too. Earl, anything interesting going on with UAC and J you want to talk about?
Oh yeah, we just had a meeting last Saturday, deciding how, because they're in a state park, the state park is requiring them to come up with a plan how they would be open. Because apparently they have sort of a kind of a lease agreement. And the park could theoretically just kick them out if they said, well, you're not doing enough stuff, you got to get out of there. So they have some sway over them, and they said, well, we want everyone to have a plan how. So last Saturday we started going over, they had a board meeting and they went over what they think they should do and how they would reopen. And it looks like what they're going to do initially is it'll be by appointment. They'll still have their stuff every Saturday, but you have to go online and use like eVite, I think they are using to, it'll be free, but you have to sort of ask ahead of time. And then there's going to have someone down at the gate. And if your name's on the list, you get in. If not, they'll say, oh, sorry, we can't just let anybody in. But I mean, if there's, they know they can only have like 25 people there at a time, which is a lot less than they normally have. But, if only 10 people make reservations, if you showed up, then they would probably say, well, yeah, you can come in because we're under 20 people.
Sure.
And then of course, because some people aren't coming out, some of the volunteers aren't coming out, they're down about 50% the number of people that signed up to be observers. So they've got to figure out how they're going to do this with reduced number of people. It's not too bad if it's only going to be 20 people there. On a good night, they might have 70 cars if there's no restrictions. And so that means they have to dedicate one person, 2 people just for parking. And also things like, instead of having their talk inside in their little room, it'll be projected on a wall outside. And the same thing with the observatories. They have enough equipment to have 1 or 2 observatories open, and the image will be projected on the wall of an adjacent observatory because they're all just white, or put on a screen if they have a large screen TV to put out there. And so the public will not actually go into the observatories. And that'll help them. So they don't have to worry about, cleaning everything after that. So the only person that'll be in there will be the observer.
Right. Okay,
And then
thanks,
they'll
Earl.
just sort of, move them around to the different things. A couple of the guys said they have their telescopes hooked up that they could send images across the internet. And one of the suggestions was, well, after the talk's over, you can use that projector and screen to display images from somebody else who's somewhere else at home with their telescope.
Cool.
So there's still a lot of stuff up in the air. And once they get a plan written up, they'll submit it to the park. The state will look over it and see if they like it. And they're figuring, as the fastest possible is that it'll take them 3 weeks to approve it. And they're guessing they'll have questions and comments too that'll have to be addressed. So they're figuring, they're not going to do anything. They won't do anything, for in person until at least after the 4th of July.
All right, Earl, thanks. Yeah,
No,
so
they are open. I mean,
yeah,
if you're an observer, you can go. And I'm an observer, so I can go and I can take, a few people with me if they want. And I have access to 3 telescopes up there, 3 observatories.
So this is UACNJ. It's the United Astronomy Club of New Jersey with a facility in Jenny Jump State Park in New Jersey, and Earl is our delegate to that. So thanks, Earl. Just wanted to check in real quick on that. Frank, have you been up to Pulpit Rock lately? Anything to report about that?
Yeah, we've been up there doing some grass cutting, and the site's still in decent shape. One of the things probably going to be looking at this summer is some of the exterior buildings need some painting and prep work. So probably be looking at if there's people interested in doing some exterior painting where we'll kind of keep separate. We've already purchased the paint previously, so there are some activities, but we won't be doing any of the indoor activities on the 40-inch at this point in time. And the site is open. Hamburg has opened it back up. It was closed down up until about a week or so ago. So it is now open once again for hikers and what have you to go up the road.
Sure. Yeah, speaking of hikers, I just want to mention our buddy Jim Blanford really quick, who is happy to be able to be hiking up and down our hill again at Pulpit Rock for his training. But he participated in a contest in May, a virtual contest for 7 days, and he had to do it on the trail over by Port Clinton because Pulpit Rock was closed. But it was how much vertical you could do on foot in 7 days. And he came in 3rd overall, and he was the highest for somebody who did it outdoors. 100,000 feet of vertical climbing on foot in 7 days.
Oof.
The guy is a machine. He's amazing. But he's a hell of a nice guy. You probably met him, Frank, but he's over at Pulpit Rock quite often. So
yep.
Good friend of ours. Yep. Real quick, let me check in with the other officers. Tom, Duff, you have anything you want to mention to the group?
No, nothing for me. Just waiting for things to calm down.
Okay, Tom, thanks. How about Dennis, our secretary? You have anything you want to bring up?
No, not at this time.
All righty. Thank you much, sir. Anyone else who's present have anything they want to bring to the group before we consider it wrapped up for the night? I see another chat message there. Did I miss? Oh, Bill Malcolm says Malcolm says he has a good source for powder coating. Bill, would you please look up Frank Leiter on our webpage? He's the Pulpit Rock Observatory's director, and send him an email because he's researching that right now. In fact, Frank, if you don't hear from Bill, let me know. Gwen and I have his email so we can get you in touch. But
yeah, appreciate that.
Yeah, he sent a chat message. He has a good source for powder coating.
I do.
Awesome. Yeah, if you would get in touch with Frank and let him know, that would be great because we are definitely looking into that. Big hunks of metal, big telescope. Okay, well, I guess we'll call that the end of our meeting. And I'm going to declare the meeting to be closed.